Good day. We'll be designing the water retaining structures and this tank, which is an anchor. We check for the uplift by checking the dead load of each and every one against the soil pressure and making sure that the tightness class is 3, which means no leakage permitted. And what should we do? And the load factors which are to be used is 1.35 for the permanent action and 1.2 for the height of water which will act on it. So we have different cases which will be act on this wall. So I'll only be treating just a case when the tank is empty only and the soil pressure is acting on it, including the groundwater outside the wall. So this is the tank I'll be using for this example. This is a gradual class whereby later on I'll do the full modeling and check the brace pressure and the soil interaction with the slab. So let's say the height of this wall is 4.65 and the water level is 1.0. and this width is about 7.6. so I'll model this part and I will show you the pressure acting on the wall using robust structural analysis. Then I will model the full wall and show you the reaction and the pressure on the base slab, while I will design the slab and the top of the slab. Also I will also design the wall and detail it in Revit for every one of us to see. Okay, so this is my robust structure interface. So I'll come to my structural ASICs and add y. This is 7.6. I'll go to my y, I'll leave it on 0, then I'll leave this on 4.6. let me confirm. Yes, that is 4.65. then I'll click on add. No, what have I done? I'll delete, then I'll click on add. I'm sorry, please delete all. Number of repeats is 0 and position is 4.65. I'll click on add, then I'll add 0 back, I'll click on apply, I'll click on close, then I'll click on the home button for me to have it like this. So now I want to draw the wall, so I'll assume I want to use a wall of 400. So let's come here, I'll come to my object, click this and make sure it's like this. Then I'll click on close, I'll come to my panel, then okay, let me do it like this. Structural elements, I'll come to my wall, I'll define my wall. So I'll call this my wall 400. Let me say 400. I'll remove this option if it's still, and I'll click on add. I'll use the cylindrical strength option 5, add, then I'll click on close, I'll come to my panel, I'll choose my wall. I'm using shell, so I'll pick the internal point, which is this. Then this is my wall here. I'll pick on my wall, so I'll do this. I'll come to my option of mesh, I'll choose on this and choose on dynasty, advance, and I'll choose on this. I'll click on OK. Then I'll mesh the wall first. Then this is it. I'll have this option of no support. I'll click on close. I'll click outside. Then I'll come to my support. I need a node down support and fixed support. Then I'll pick on this node here, but instead of applying on node, I'll just make this option and put this structure right. I'll relight, Alright, so this is the node here. I can copy it if I want. I can copy, then open this, and I'll have it here already. Just click on apply. So these are the fixed support. You can come here and do the same thing. No, I want to put it on the node. So come here again. You are light. So you have it here, then you bring it down, you apply the another support. So you do the same for this, come here, click on support, you apply, then we pin the top, and just come and align the upper one, then you click on apply, then we click on close. You can view this structure better like this. So now I'm going to create my load cases. I'll come here to define load cases. My load case 1, which is my self weight, then I'll call this my, so let me call this my surcharge. Let me change it to surcharge. Let me modify, and why is it not changing? Surcharge. Then I'll come here again. I'll define these load cases. Let me write the name for it. I'll call this my pressure due to the earth flow, which is this one. Let me show you from here to here. Since this wall is about 4.65 minus 1, so we have about minus 1 is 3.65. so, and then if this soil is 18 kilonewton minus 10, we should have about 8. So then I'll come here, I'll call this my submerged, earth. I'll click on add, then I'll call this my pressure due to groundwater, which is the groundwater here. Then I'll click on add, then I'll click on close. So now I'll apply this load. Now I'll come here, I'll come to my surface load, I'll pick on this, then I'll apply my surcharge load here first. Surcharge, which is 3.75, or did I use, let's say 4. Let me use 4. Add. So I'm applying it to this guy here, and this should be 1. Apply. So as you can see, this is my surcharge load acting on the wall. I'll come to the other one, submerged earth. I'll pick on this value. So this should be let's say let me say 800. So from which height to which height, that is 4.65 minus 1 is 3.65. So I'll add, I'll apply. Okay, there is a mistake, sir. Ctrl Z, submerge on this direction. I'll add, I'll apply. So this is it here. So now my pressure due to groundwater. I'll come here, still the same. So the groundwater, let me just let's see, still from here downwards here, but I can just assume that all these pressure are acting downwards here for me to be on the safer side. So I'll just go back and delete those two loads, or I'll just apply the groundwater fully to it. Okay, .65, water is 1000 kilogram per meter cube. 1000. I'll add, I'll apply. So I'm not really satisfied with the previous loads that I had to it, so let me change it. I'll come here to my loads, and where is it? This is it here. I'll change it back to 4.65, and I'll hit on my screen. So now I'll come back to my combination, that is loads. Now I'll use manual combination for this. So I'll call this my tank empty. Tank empty, when my tank is empty, which is the most critical case here. And I'll pull this guy here using a value of 1.35. I'll shift it, which is this here. I'll pull it out. Then for the surcharge, I'll use a value of 1.5. Use a value of 1.5. Then the submerged earth field, I think this should be submerged earth field. I'll use the value, let's say 1.4. And then for the groundwater, this is surely 1.2. So I'll come here, I'll click on apply, and I'll hit on close. Go back to my structural model, click on my geometry. Then I'll click on my calculation to check if I have any errors or warnings. So as you can see, I have 0 errors, 0 warning, and I'll close any other tabs here and bring back my structure properly. Then I'll come to my results, then I'll come to maps for me to show you the maps. Then I'll view the stress here. So the moment in the x direction, which is trying to turn the plate, y the moment in y, and the y, this is the torsion, which is trying to twist the plate. So also for us to see the moment in the x direction, so this is it. Okay, so my combination is current tank is empty. So the maximum is occurring at the bottom part of the plate here, that is the vertical, and then the y will be at the edge here. Let me apply for you to see. So can you see the maximum here is 94, and this, so this is trying to twist the plate on this top part. Why, if you should check very well, this is trying to turn the plate here, turn it at this edge. Why this is trying to rotate at this part here and at the other pen there. So just click on apply, and I'll take out the option apply, close. Then I'll come to my my design, provided RC elements, though I might just okay, let me do it first. Provided RC elements, so it's loading. So this is it here. I'll click on close. I'll bring it closer to the slab reinforcement maps. This is it here. For the top, bottom. So what I'll do now is I'll come to the reinforcement button, then I'll change it from wire fabrics to bars. Then I'll make sure the bar diameter I want to choose is, let me take Y16, take Y16, take Y16, take Y16. Okay, so let's leave the rest and click on OK. I'm done the drawings. Okay, I shouldn't be coming here first. Let me calculate first. Let me run my calculation first before coming to the drawings. So let me run my calculation first before generating the drawing. Let me generate the drawing and calculate. So now I have my drawings here. So as you can see, the reinforcement, this is it here. So 16 the shape, and okay, so let me show you the 3D reinforcement here. I'll come here. This is the list of possible solutions here. Then I have my spacing of 380, which is too much. If I should consider other factors like the crack width, and so I have this space very decreased downwards here, but let me reduce it first myself. So bars, so I want my maximum. Okay, so look at it here. The spacing is 19. So slab reinforcement, so this is it here. I have it, so I can, it's better presentable like this. And let me try and rotate it properly. Front, side. Okay, so now this is it now, and this is the other bar, but reinforcement I want to view both the top and bottom together. So I can come here and view both together. Come here, trying to pick a better view of it. Can you see? So I think this is better. Don't know what is wrong with my mouse today. This is misbehaving. So I can edit some things here by changing the reinforcements and that stuff. Structural model geometry. Okay, result again. Let me go back to my maps and principal enforcement, apply. Okay, so we should notice why robot was detailing. We have the reinforcement more concentrated at this angle, showing more stress pattern than the other one. to the shorter direction, then this the compressive reinforcement in the shorter direction. I'm coming to my principle, and apply. Okay, so during my next class I will show you the comparison between this and Start Pro, so for us to know if there is any difference in my method of application of my model. So I hope you guys will enjoy the class, and in my other class I'll model the full tank. Thank you.